So hello everybody, welcome back to iScholar. So as we discussed, we are having this series in which we'll be discussing each and every question for the HC capacitor chapter. Now coming to the second video for this. In this, we'll discuss the question from question number 11 to 20. From 1st to 10 we have already discussed. So let's get started, students. So from the 1st to 10th we have already done, and if you have any doubt you can also let me know in the chat box. So let us start with this question. It is given that we have two cylinders of the capacitance value is given, so I'm writing it over here, which is given as to be 2.2 microfarad. The capacitance is given to you, are kept in contact such that the inner cylinder is connected through the wire. A battery of the EMF 10 volt is connected as shown. Find the total charge supplied by the battery. You need to find the total charge supplied by the battery. Okay, let us first understand what is the total capacitance. See, C is the capacitance for one, but in this question you have these capacitors which are connected over here. Let us try to understand how we can say this. See, in this it is given both of them are connected to this potential. This outer part is connected to this. That is, both the capacitor, outer this radius, outer part is connected to the higher potential V, while their inner part is also connected by this same wire. Can I say that the outer part is connected to one potential while inner part is connected to another potential? Can we say that it is in parallel? Because both of the parts are connected to same potential, right? So we can just say that since the potential difference between both of the cylinder is same. Note this is the main key point. Potential difference between these two cylinders are same. So I'm saying the total capacitance would be in parallel, and the total capacitance would be just C1 plus C2 since they are in parallel. Now, what is the value for these? So this will be 2 into 2.2 microfarad, and you will write it as 4.4 microfarad. Am I clear with this? So the total capacitance is given by 4.4 microfarad. Now what is asked? Find the total charge supplied. You can just use total charge supplied would be Q is equals to C into V. The total capacitance is 4.4 10 to the power minus 6, and the voltage would be 10. From here you can write it as 44 microcoulomb. I hope I am clear with this. Coming to the next question. Next is two spheres of the radius R1 and R2 are kept separated from each other. What are their individual capacitance? Okay, so it is just like you have a metal sphere whose radius is R1, and you have another sphere whose radius is R2. They are connected in such a way. Okay, so what is the individual capacitance? Okay, let us try to understand the concept. The total capacitance is formed by two metal conductors. So it is very clear one of this conducting sphere, one we have. What about the other? Where is the other kept? So in such type of question where we just have one metal conductor, we assume the other one is placed at infinity, and the total capacitance is formed by these two metal conductors, first and the second. So the total capacitance, if you have two metal conductor, for example if I say that something like R1 and R2, if it is given, the total capacitance, students, is given by 4 pi epsilon naught R1 R2 divided by R2 minus R. While if you say that one of them is at infinity, like in our case we are talking about, if you say that one of them is in infinity, we'll say the total capacitance of this become as to be, if the another one is in infinity, this is simply 4 pi epsilon naught R1. If we have a conductor of R1, assuming the other one is placed at infinity, R2 at infinity. Clear? Now, so in this question we have two capacitors, different capacitors of this potential. So the other capacitance will become 4 pi epsilon naught into R2. So got the value for both the potential, right? Now, what will happen if we connect these by a metal wire? Again, you can assume these are the two metal conductors R1, R2. If I connect them by a metal wire, what I am doing? I am basically equalizing their potential. Now these both will have the same potential, right? So, see, now try to understand, are they in series or they in parallel? The one of the metal conductor, the one of the metal part is connected to the same potential. What about the other? That is at infinity. That is at zero potential. So that the other part is at zero potential. Other part of this is zero potential. So basically one metal again connected to same potential, another also at same potential. These two capacitors also are lying between same potential difference. So I'll be writing it over here. The total capacitance would be just the addition why they are in parallel. Epsilon naught R1 plus R2. They are in parallel, so we'll just add them like this, right? Coming to the next question, what do we have? Each of the capacitance has a capacitor 2 microfarad. Find the equivalent capacitance of the assembly between the points A and B. Okay, so what will be the equivalent capacitance? If I make it the point A, the and B, these three are in series. If we have equal capacitance in series, we'll write it as to be, simply students, this will be framed as 2 by 3. I have told you so many times the total capacitance will be given as C, capacitor for 1, and divided by the number of parts you have added them in series. So this will become C by N. You will write it over here 2 by 3. Again it will become as to be 2 by 3. Again it will become as to be 2 by 3. Now these three are in parallel. What we'll do? We'll add them simply. This will become as A and the point B, and we'll write it as the total capacitance. Add these three, what will become? It will become again 2 microfarad. So the total capacitance between A and B is 2 microfarad. Now it is given, find the equivalent capacitance. We have done. Suppose a battery of 60 volt is connected. Find the potential on individual capacitance. Okay. So it is like, you can do it simply also, if it is like 60 volt is given over here. So can I say, students, since they are in parallel, each and every one will get 60 volt, 60 volt, 60 volt. Each branch, these three capacitors collectively get 60 volt. Since they all are identical, so can we say that this one will get 20, this one another 20, and this one another 20. So collectively 20, 20, 20. What was asked? This was the only question. So you can write it as the potential on the individual capacitor would be just 20 volts. I hope this is clear to you all. Coming to the next, it is required to construct this much capacitor at this voltage, and what is given to you. Okay, so you are given with a 10 microfarad capacitor that can only withstand a voltage of 50 volt. You want it to make it till 200 volt, and the value should be, capacitance should be 10 microfarad. How can we do this? See, look. First of all, I'm saying that the capacitor which we are given have a capacitance of 10 microfarad, and they can withstand a battery voltage of 50 volt? Right? I collectively want to make 200 volt. Okay. So first we walk to the voltage and try to make such configuration. I have 50 volt. I want to make it in 200 volt. Okay. Just look at this. Can I do it like this? One can give me a voltage of 50. So I choose 4 of them. 50, 50, 50, 50. Since they are in series, collectively potential would be 200 volt. 50, 50, 50, 50, that would be 200 volt over here. So I'm writing, this will become 200 volt. But the issue is, the total capacitance will become, see, it is 10 in series. Now we are connecting 4 such in series. So the total capacitance would become C by 4. Or it will become as to be 10 by 4. But our target is to achieve 10 microfarad. What should we do? We'll do it as, now I'm taking same branch. This had a capacitance 10 by 4. I want to make it till 10. So I'm taking 4 such branches which will become in such a way. Third and the fourth branch. Now see, this one have a voltage 10 by 4 capacitance, 10 by 4 capacitance, 10 by 4, 10 by 4. Can I say that collectively, since they all are in parallel, so the total capacitance would be 10 now. Also, what about the voltage? If this branch have 200, now these 4 are in parallel. So obviously the voltages along them would be same, and you will write it as the voltage would be 200 volt only. Am I clear with this? Coming to the next, take the potential at the point B to be 0. Okay. Find the potential at the point C. We'll try to calculate the potential at the point C. Okay, how can we do this? First, we'll try to simplify the structure. This is the point A. We have 2 capacitance. This is the first capacitance, second capacitance, which are connected to, okay, 50 volt. Now tell me, students, these 2 capacitors are in series. So collectively, what I can write them? The collective potential would be just, they are in series, so I'm writing C1, C2 divided by C1 plus C2. This will be the effective value because of these two capacitance. So it will become as 8 into 4 divided by 12, which will become as 8 by 3 microfarad. What about these? So again you will have 3 and 6. So I'm writing the capacitance would be 3 into 6 divided by 9, which will be 2 microfarad. So now one thing is clear, we have 2 branches. The upper one have a capacitance 8 by 3, lower one have a capacitance 2. Voltage which is connected over here is 50 volt. Okay, so I'm saying that if 50 volt is coming from here, it will go, and can I say that I'm calculating, students, I'm calculating the charge flown in this. What is the advantage? If I know the charge flowing through this, I will apply. I'll just simply calculate the potential between these 2 points. Let us see how. See, the charge flowing through this upper capacitor would be just Q is equals to CV. Potential, since they are in parallel, so I'll say the potential is same for everything, which would be 50, and the capacitor of this part would be 8 by 3 microfarad. Can I say the total charge flowing from this upper branch would be 400 by 3 microcoulomb. So this is the charge which is flowing through this part. Now, if I say that in the upper branch 400 by 3 coulomb is passing, does it mean that same charge will be passing from this and this part? 400 by 3, 400 by 3. So we can just write it as, if 400 by 3 is passing. See, now what I'm doing, I'm just applying this law. I'm saying that potential at the point A, I am just writing it for just one capacitor over here. I'm using this equation, Q is equals to CV. It says that charge flowing on them, we just calculated, which is 400 by 3 microcoulomb. I'm writing this is for micro, is equals to, capacitance is 4 micro. Obviously this micro get cancelled into the potential difference. So the potential difference between these would be, you will say VA minus VC. Now if this point is 0, which is given, the purpose of battery is to create a potential difference of 15 case. If it is 0, obviously this part is 50 volt because it just create a potential difference. So I'll write this would be 50 minus VC. What is the point VC? See, we just wrote an equation to calculate VC. From here you can just use and calculate. This would be 100 by 3 is equals to 50 minus VC. From here VC can be written as 50 minus 100 by 3, which would be 150 by 3, and it will be 100 by 3. Clear? So we calculated the potential at this. Now next is potential at D. Similarly, students, this is your task, this is your homework. You will do this. When you will calculate using the similar procedure, same, everything would be same for the lower branch. Interestingly, you will get the same potential here. The potential at D would be also 100 by 3 volt. Okay, and this is your task. You will be doing it similar path, nothing different. What charge will appear on the capacitor? And now they are saying that if the capacitor is connected between CD, if you are connecting anything between C and D, students, we just saw they are at the same potential. If they are at the same potential, no charge will flow. Whatever you connect, if there is no potential difference, there is no charge flow. Next is this question. We have to calculate the equivalent capacitance. How can we do this? This is the point A. Obviously, C1 and C2, these two are in series, so I'm writing it in series, and this will become as C1, C2 divided by C1 plus C2. This is C3, writing it as it is, and another capacitor over here, C1, C2. Again, C1 and C2 are in series over here, so we'll be writing it over here, C1, C2 divided by C1 plus C2. Now we can easily say that these all are in parallel. If they are in parallel, the total capacitance would be, just add all this. So it would be 2C1 C2 divided by C1 plus C2 plus 3. So this is the total capacitance got over here. Next is a capacitor which is made up of the plates area. Now let us deal with this question. How can we say this? First of all, we have to understand what are the individual capacitance and how are they connected. So students, these are the plates. So basically the charge is going through like this. Now try to understand, this is made up of 3 different capacitors. How? You can understand the first capacitor having this much plate area. The second capacitor, this part, these are the plates. And the third capacitor, these are the plates for this. So we have 3 capacitors. First, I will write the capacitance of all. So C1 value, I'm writing it as to be, which one would be epsilon naught area. See, if area of this whole plate is 3, what is the area of the first plate, first capacitor? You'll be like, that would be simply A divided by the distance between them, which is D. Coming for the C2, the C2 will be written as for this capacitor. I'll write it as epsilon naught. What is the area? It is 3A, the area would be A, and the distance between them. What is the distance between them? I'll write it as D plus. Students, can I write it as this is D and this is B. So the total will become as D plus B. What about C3? The capacitance C3 will be given as epsilon naught area divided by this distance, which would be D plus B plus B. So I'm writing it as to be D plus 2B. Okay. Now let us try to understand they are in series or they are in parallel. See, when the charge is coming from here. Now if you can see, we have 3 different capacitors. So students, basically the charge have 3 different paths to flow. It can either go from here, or from here, and can move to till here. What I am saying is that all these 3, either you can say them as they have the same potential. Why? Because these are connected to the same potential difference. Or you can say the charge the charge can be flown into different amount. Charge flowing from all of these are not same. Charge have 3 different paths. It can go like this. This is in parallel, and we'll say that the total capacitance in parallel is just the addition. You will just add all these 3 and you will get the answer, which is to be 1 by D plus 1 by D plus B plus 1 by D plus 2B. This is the total capacitance for it. I hope it is clear. Coming to the next, we have a cylindrical capacitance is constructed using the same length and radius. Okay, so we know that the capacitance for a cylindrical capacitor is given by ln R2 by R1. What is R2? This is the capacitance. The inner radius of R1 radius, the outer part of R2. So the total capacitance is 2 pi epsilon naught L ln R2 by R1. You can also write the value for this simply. You can just put the value 2 pi epsilon naught into the length, which is given as to be 10 centimeter ln R2 by R1. Outer radius, which is 4 mm, and the inner one is 2. So this is ln2. We know the value of ln2, which is 0.693. So this is your task. You'll be calculating the value of this and will be writing in the chat box. Okay. Coming on this is another capacitor which have different radii value. Interestingly, students, the capacitance will come same. Why? This is of the radius 2 and 4. If you will divide them, ln R2 by R1, which will be got as 2. If you divide these 2 also, they also will come in the ratio of 2, and you will see the total capacitance will be same for both. Coming to the next question, we have capacitor is charged to potential. So whenever such type of question comes, when one charged potential, another may be uncharged, may be differently charged, are connecting together without any battery or anything, the total common potential between them is given by C1 V1, C2 V2 divided by C1 plus C2. In this question we have, initially one was uncharged, so the potential over here would be 0, and the common potential afterwards in both of them would be First capacitor, 100 picofarad, 10 की power minus 12, potential difference of 24 divided by the total capacitance, which is 100 plus 20, 120 picofarad, 10 की power minus 12. This will cancel out, which will become as 20 volt. So collectively they will have 20 volt on both of them. Coming to the last and the next question, we'll say that each capacitance shown has a capacitance which is given as 5 microfarad. The EMF of the battery is 50 volt. How much charge will flow from A and B? Okay, so if the switch is closed, first of all, if we have to calculate how much charge will flow, we'll calculate the initial charge which is flowing. Okay, for initial charge, we'll take this circuit and calculate the C equivalent over here. Initially, beta, if it is not closed, the total capacitance would be these two in parallel along with this in series. So the total capacitance would be these two are in parallel along with this series. They are in parallel, this would be 2C, which is series with this. So we'll write 2C into C divided by 3C, which would be 2C by 3. Now what is the total charge flown in the first case when it is open? So you will write that is CV, which would be 2C by 3 into V. Now when you connect this switch, when you switch it open, what will happen? As soon as you open it, the complete charges will flow, or I'll say as the switch is closed, now the current path would be just like it will be passing from this, and instead of passing from the capacitor, it will pass from the wire itself. We'll say the capacitor is short circuited. No charge will pass from here. And in this case, in the next case, the total capacitance, second case, total capacitance would be 2C. Why? This is short circuited. This is short circuited. This will not come into count. Total capacitance 2C. So you will write the total charge would be Q is equals to CV. And the total charge would be 2C into the potential. So in the question it is asked how much charge will flow. So how much charge will flow? You will say the Q final would be flown final charge minus the initial charge, which is just 2CV minus 2CV by 3, which would be 4CV by 3. I hope students this is clear to you. So that is it for the today's session. In the next video, we'll do the next 10 questions. Thank you all.